In this video, we are going to perform a chi-square test for trend, a special type of chi-square that you should use if your categorical independent variable is ordinal and you want to establish a relationship between it and a binary outcome. Here is the dataset that we are going to use, which you can download using a link in the description of this video. It has got two variables. We have age group and hypertension. Hypertension is our outcome, whether someone has hypertension, yes, or does not have, no. Then our independent categorical variable is age group. Hypertension is coded as 0 for no and 1 for yes, whereas age group is coded as 1, 2, 3, and 4 for these different age groups. So the question here is, does the likelihood of hypertension increase across the levels of age group? So here the most appropriate test would be a chi-square test for trend. Because when groups are ordered, you expect the changes in proportions of the outcome to differ across those different groups. So to run a chi-square test for trend, simply go to Statistics, Epidemiology and Related, then select Table for Epidemiologists, and then go down to Tabulate Odds of Failure by Category. Here, you're going to specify our case variable, the outcome variable, which is hypertension, and our exploratory variable, which is age group, our ordinal variable. Then you want to report odds ratios, and by default, the first group of that categorical ordinal variable will be used as the reference, and then you click OK. In this table, we have got our ordinal independent variable with its different categories. Then we have the odds ratios for each of the categories, but you notice that the first category has an odds ratio of 1, indicating that it is the reference category. All these other age groups are being compared to it. When interpreting odds ratios, an odds ratio of 1 shows that there is no difference, whereas an odds ratio above 1 shows that that group has a higher likelihood of getting the outcome, in this case hypertension, compared to the reference category, here 18 to 29 years. So if we are to interpret this odds ratio of 5.5, we would say people aged 30 to 44 years are 5.5 times more likely to have hypertension compared to those aged 18 to 29 years. Same thing if we are to interpret the odds ratio of 40, people aged 60 years and above are 40 times more likely to have hypertension than those aged 18 to 29 years. This is just hypothetical data generated to illustrate how this test is run. Next, we have the chi-square values here and their p-values. We can say that the p-values are all statistically significant and they are 95% confidence intervals. Below this table, we have got two sets of tests. We have the test of homogeneity, equal odds. That's like the normal chi-square for independence. We have it is chi-value and the p-value, which is significant. But here we are interested in the score test for trend of odds. That's the chi-square test for trend. We have the chi-square value and then the p-value, which is statistically significant. So this statistically significant value tells us that the odds of having blood pressure systematically change across the different age groups. And this systematically change, in this case, systematically increase as you move from one age group to the other. We therefore reject the null hypothesis that states that there is no linear relationship or no trend in the odds of the outcome across the categories. Clearly, we can see that the odds of having hypertension linearly increases as you move from one age group to the other. If you find this video helpful, consider liking, commenting, and subscribing to our channel so that you don't miss out any of our episodes. So next we are going to look at a special kind of chi-square called the Manto-Henzel chi-square, which you can use to adjust for a third variable or a confounder. See you in the next video.